Hello guys, welcome to Learning with Lai. This is the continuation video on how to take readings from Vernier Callipers and Micrometer Screw Gauge. The Micrometer Screw Gauge is quite different in structure than the Vernier Callipers, and it is used for measuring the diameter of a piece of wire, thin rods, and object of similar small distances. So let me show us an image of micrometer screw gauge in case you might have forgotten. And here with me now from the previous video which I showed us before, we have the micro screw meter gauge with some part labeled, where we have the frame, the anvil, the spindle, the lock, the thimble, the ratchet knob, the sleeve, and this part here now is the digitized image of micro screw meter gauge, whereby this main scale here is actually what is zoomed for us here to see, and we have a rotating scale, we have the thimble, and the object is actually placed in between the spindle and the anvil, and we can use that to measure the distance of, or the diameter of the thin rod or the object that is placed there. So now it is used, and what we should know is that there is always a pitch of 0.5 millimeters in the screw of the thimble, which now yields that 50 circular division is actually equals to 0.5 millimeters, and 1 circular division is actually equals to 0.1 millimeters. So we have 50 circular division is actually equals to 0.5 millimeters, and 1 circular division is actually 0.01 millimeter. And I'm actually going to explain this better. So now, and also in that same pitch where I mentioned that it is of 0.5 millimeters, the pitch that is in the screw, which is 0.5 millimeters, it means that for one revolution of the screw, the spindle moves forward or back 0.5 millimeters. Now let me take us back to that image. So now in this part here, now inside this thimble here, there's a pitch inside which is of 0.5 millimeters. So when we turn our micro screw meter gauge, it moves forward or backwards, and that is occurring at one revolution. And since it's moving forward and backward, it is going a distance or covering a distance of 0.5 millimeters. So now that's the main idea that we need to know. So what we actually need to take note is that since we have our main scale here, we take down our readings, then we'll now add that readings to the um the circular division that we have. We convert it almost like a similar case of the vernier scale, whereby you convert the vernier division to either centimeters or millimeters, depending on the manufacturer's unit degraded on the vernier scale. So now in this case here, now we need to, if we want to know the actual distance of this object here, what we're going to do is that we're going to take, so let me do it here on this page. The distance of the object D will be actually be equals to main scale reading plus rotating scale reading. So now I can also write it out on this micro screw meter gauge, because I'm not actually going to repeat it. So now the distance of the object, let me write a distance of object is actually going to be equals to the main scale reading plus the rotating scale. Sometimes it's also called the drum. Circular on the rotating scale rather is always having 50 circular division. On the micrometer screw gauge, it has 50 circular division. So for us to now actually know the millimeters of the actual division, the circular division that coincides with the main scale, because what we're actually trying to look at is the circular division that coincides with the main scale, so then we now convert it to millimeters. And in most cases, the unit on the main scale is always in millimeters, and while that of the circular division, the rotating scale reading, is actually equals to, is also in millimeters. So now let me now take us to some examples that I'm going to solve, and there'll be a classwork which you can try to test your knowledge or understanding of it. So here now I have some readings of the micrometer screw gauge with me, and we're going to actually write down the readings, because this has, we can assume that the micrometer has been turned, and this is the final position whereby the spindle and the anvil are actually holding on to the object. And we actually have a lock here in case if we remove the object, so that the anvil and the spindle doesn't shift from the initial position. So now we have our readings noted now. So all what we're going to try and figure out is at what point, this is our main scale. Let me point it out. So this is our main scale, and this is the rotating scale here. And in most cases, they are always in millimeters. In most cases, they are always in millimeters, especially the um, rotating scale. It is always in millimeters. Now the main scale might depend on the manufacturer's choice, whereby you can choose to put any other metric unit, maybe centimeters, but in most cases the rotating scale is always in millimeters. In most of the textbooks I checked before making this video. So now, how do we take down our reading now? Now the formula to get the distance of the object, which I tagged D, is actually, and again sorry for that, I omitted something. So now our rotating scale reading is going to be, okay, we'll actually solve it here. So now our main scale reading is actually at what point. If we look at this now, this is actually main scale, because the distance of the object, which I've already written, that I can write this as main scale m dot s plus rs. So and our main scale reading now is, that's what, 8.5 millimeters. Now how do we now get our rotating scale? Now the rotating scale is always in circular division, just like our vernier scale. Our vernier scale, we count it in vernier division, then we use that standard conversion, that one vernier division is actually equals to 9/10 millimeters, and in centimeters that will be 9/100. But in this case here now, we have our rotating scale, and since we already figured out that for one circular division, that is going to be equals to 0.011 millimeters. Therefore, for, and if you look at it now, the point of our coincidence with the main scale and our circular division is actually going to be 27, because this is 25, this is 26, 27, 28, 29, 30. So this is the point, and that means for 20 circular division, that will now be 27 rather times 0.01, and we have millimeters here now. So that will now be actually, so from here now we'll now simplify this further, and this will be 8.5 plus 0.27. Since they are both having the same unit, I don't need to repeat that. So that will now be 8.77 millimeters. This is quite straightforward than the vernier scale. Now let me do B. So now to solve for B now, if you look at it now, this is starting from 0. That's why I close this part here now. So now you can see it now that the main scale reading is actually, our distance is equals to, what's our main scale reading? So that's actually 2 millimeters. So I have the unit of all this main scale and the rotating scale. Rotating scale in most cases is always in millimeters, and for the vernier scale and the main scale is mostly not, that's manufacturer's choice. That's, could be either the main scale is always in centimeters, whereas the vernier scale is always in millimeters. But for the micro screw, for the micrometer screw gauge, the main scale is actually in millimeters, while the, in some cases, depending on the manufacturer's choice, but the rotating scale is in most cases always in millimeters. So now we have this also millimeters, and we have this also in millimeters. So now to calculate the readings from this micrometer screw gauge, so we have our main scale reading to be 2 millimeters plus our rotating scale. Let me change that. Our rotating scale is actually, that's plus. So now what point does our rotating scale coincide with the main scale? And if you look at this, that's at 9 circular divisions. So this will be 9 times 0.01 millimeters. So now when we solve this, this will now actually be 2 millimeters plus 0.09 millimeters. So now our final answer is now actually going to be 2.09 millimeters. So now we can try and solve these other ones to check our understanding about how to take readings from a micrometer screw gauge. So now I'm going to write out the answers for these other ones here. And the answer for this one, let me use that in another pen. So the answer for C is actually 10.15 millimeter, and for D the answer is actually 12.35 millimeters. So there you have it, guys. If you have any other short suggestion or comment, please kindly drop them below. And if you love this video and you found it educative, please click the like button and subscribe. Thank you.